A journey of 1,000 miles starts with a single step. Hello my dear students, welcome to the channel. This is your Annapurna ma'am, and today we are going to learn about the periodic properties of elements. Now children, there are 118 elements which occur both naturally and as well as some of them are man-made. Now the elements which have atomic number of more than 92, they are man-made. They are also known as synthetic or transuranic elements. Now the elements which have an atomic number below 92, they occur naturally. They are natural elements. Now these elements have been tried by many scientists, chemists, to arrange, to place them in a proper periodic table, but they failed. The most accepted periodic table of elements was of Mendeleev's, but it had few mistakes which was then rectified by Henry Moseley, an English physicist. In 1869, Dimitri Mendeleev, the chemist, he started to arrange the elements and place them according to their atomic masses. He had many experimental evidences to show that the periodic properties of elements are periodic functions of their atomic masses. Now, again in 1913, it was Henry Moseley who demonstrated that it was the atomic number which is the fundamental property to classify the elements. Now, Mendeleev, while arranging the elements in his periodic table, he even predicted the discovery of few elements, and even he left open spaces in the periodic table for those elements to be occupied. So now Henry Moseley, he through his X-ray spectra, he could show that atomic number is the main factor to define the periodic properties of elements. He was the only scientist who could calculate, who could find out the number of protons present in each element. So the periodic table, the modern periodic table, has all the 118 elements arranged in a systematic and organized manner, so that we can easily study the properties, the chemical, the physical, and how do the elements react by just looking at the position of the elements position in the periodic table. Now the periodic table, the whole of the table has been divided into 18 vertical columns known as groups or families, and it also has 7 horizontal rows which are also known as the periods. Now the elements which are present in a single period has a common factor, that is, all the elements, they have the same energy shells in them, and the elements which are present in the single group, they have the same valency, that is the same number of valence electrons in their outermost shell, that is the valence shell. Now these elements, they have many properties. They show properties which are similar in many ways. Now these properties, they correspond to the electronic configuration of these atoms. Now, there are many properties. Now, let us study them one by one. Now, atomic size. Now, what is atomic size? This atomic size of the atom of elements is closely related to the atomic radius. Now, what is this atomic radius? It is the distance, is the measure of the distance between the nucleus of the atom and its outermost electronic shell. So, atomic radius is like the more the atomic radius of an atom, the more will be the size of the atom. So, now what is nuclear charge? Now, the number of protons relates is equal to the atomic number. We all know that. More the number of protons, more is the nuclear charge of that atom. And the atomic size, the more we see across a period when the atomic number goes on increasing, because the elements have been arranged in the periodic table in the increasing order of the atomic number. So, more the atomic number, the nuclear charge goes on increasing. So, now let's study some properties, the periodic properties shown by the elements which vary across a period and along when we go down the vertical column, that is down the group. So, first is the ionization potential. Now, ionization potential is also known as the ionization energy. It is the amount of energy that is supplied to an atom to remove the most loosely bound electron. Now, after the atom is supplied with some amount of ionization potential, it gets converted into a cation, because by the loss of electron, the atom acquires a positive charge. So, ionization potential, it is the amount of energy which is supplied to an isolated gaseous atom to convert it into a cation under the similar conditions. Now, how does this ionization potential vary among the elements across a period from left to right? And how does it vary? What are the variations it shows when we move down from top to bottom down the group? Now, as we know, the elements, now let's see across what happens across the period. Now, elements are arranged in the order of the increasing atomic number, that is the number of protons. Now, as we go across a period, what happens, that is the atomic number goes on increasing. It goes on increasing, thereby also the nuclear charge. Now, when we look at the atomic size, when the number of proton goes on increasing, the atomic number goes on increasing, but while in a period we know that all the elements possess the same energy levels, energy shell. So, with the addition of more electrons to the outermost shell, there is no extra shells being added, only the electrons are added. As a result, what happens? The nuclear charge goes on increasing and there is a greater pull. A force of attraction is more towards the electrons, in between the electrons and the nucleus. So, a greater pull of force is there, thereby the outermost electron, the outermost shell comes closer to the nucleus, thereby decreasing the atomic size of an element. And as a result, what happens? Across a period, the ionization potential goes on increasing, because we need more energy to remove, the more energy is required to remove an electron from its shell, outermost shell, because they are tightly held to the nucleus towards the, because there is a greater nuclear pull of the exhibited on the electrons. And what happens while we come down along the group? Now with the when we come down the group, the atomic size increases with the increase in the atomic number, and successively more shells are being added. So even the nuclear charge goes on increasing. With the more number of shells, the atomic size increases, and thereby the atomic radius also increases, and the outermost shell, outermost electrons, they are less tightly held by the nucleus. There is less force of attraction between the nucleus and the outermost electronic shell. So we see that ionization potential goes on decreasing because less energy is being supplied to remove. We can easily remove any electron, outermost electron, by supplying less energy. So we see there is the ionization potential goes on decreasing down the group. So now the other property, that is electron affinity. Now what is electron affinity? It is the energy, the amount of energy released when an electron is being added to a neutral gaseous atom, an isolated gaseous atom. So what happens when we go across a period from left to right? Now when we go left to right, we see that the atomic size goes on decreasing due to the more nuclear charge. So the electrons are tightly held towards the nucleus. So there is more energy being released when an electron is being added. So, and the neutral gaseous atom is converted to an anion, that is, it possesses a negative charge on it. So as we go across a period, we see there is increase in the electron affinity. Affinity, that is the attraction, love for electron. So it attracts easily the electrons with more energy being released. And what happens while we go down a period? The electrons are less tightly bound towards the nucleus. So what happens in this is less energy is being released when an electron is added to the atom. Now the next property is electronegativity. Now what is electronegativity? There are some atoms which are bonded to other atoms. This is the property shown by the bonded atoms. When these atoms, they are bonded to any other atoms in a molecule, there comes this existence of electronegativity. It is a tendency to attract the shared pair of electrons towards itself, the atom. So this is seen by the bonded atoms. Now what happens when we go across the period? We see an increase in the electronegativity, because as we know, atomic size goes on decreasing and the electrons are more towards this nucleus. They are more near to nucleus. So they are it is showing an increase in the electronegativity, because the atom, it pulls the nucleus pulls electrons towards itself. It is the tendency to pull the electrons towards itself. So across a period, we see that there is an increase in the electronegativity, and down the group what happens? There is a decrease in the electronegativity, because the electrons are far from the nucleus, and so there we can see the electronegativity goes on decreasing. Now the next property is the metallic and the non-metallic character. Now what defines the metallic character of an element? It is the tendency to it is the tendency, the ease to release, to lose an electron. That defines that's the measure of the metallic character of any element. And what's the non-metallic character? When an atom gains electron, when it gains electron easily, that defines, that measures its non-metallic character. Now there are some elements with valency, with the outermost electrons of 1, 2, 3. Now these elements, they readily lose the electrons to attain a stable electronic configuration, to acquire the octet conformation, the stable configuration. Now also there are some elements with the valence electrons of 5, 6 and 7. Now it becomes hard for them to gain or lose. It becomes hard for them to lose those electrons at 5, 6, 7. It's very hard for them to lose these electrons. So they acquire, they accept 3, 2 and 1 electron to gain a stable electronic configuration. That is the octet rule. Octet. That is a stable configuration. So, and also there are some elements like carbon. It has 4 electrons in its 4 valence electrons. Now this it's hard to receive 4 electrons or to lose 4 electrons. So carbon, it shares its electrons to attain a stable electronic configuration. Now what happens? Now this metallic character, so we can say like this, some elements which lose their electrons, they are more metallic in nature. So what is the trend we see across the period and down the group? Now when we move across the period from left to right, we see there is an decrease in the metallic character, because due to again the atomic size goes on decreasing, and the electrons, they hardly lose. It becomes harder for them to lose the electrons. So we see the metallic character goes on decreasing and the non-metallic character goes on increasing. And what happens down the group? That is when the electrons are loosely bound to the nucleus. They come closer, they remain away from the nucleus, so they can easily. Now when we come down this group, we see there is increase in the metallic character, okay, because they can lose the electrons as there is less force of attraction towards the nucleus, and vice versa, the non-metallic character goes on decreasing with the increase in the metallic character. So children, these are some of the properties which are shown by the elements, and that is how they are being arranged in a systematic order according to the properties that they exhibit. So I hope children you have understood these periodic properties of the elements and how they vary across the period and down the group. So if you have any queries, any doubts, keep writing to me. You can write to me, ask me any questions so that I can discuss it in my next video. Keep subscribing to my channel and see you in my next video. Till then, take care, bye bye, stay safe and feel safe.